everybody. Hope you're having a good week. This is going to be the Chapter 6 lecture regarding methods and event handlers. Ideally, I'm hoping that you're pretty familiar with these concepts from Java, but I want to just kind of cover them briefly to allow you to see some enhanced features that exist in C#, as well as just get you familiar with differences in syntax. So to demonstrate a lot of this, I created a week 3 app. It's basic web form. It's got 2 text boxes, some prompt labels, and then there's one label that's actually kind of hidden here. Let's see if I can, there it is, and then a button. And what this app is going to do is we're going to use it to kind of demonstrate the method functionality. So I'm going to flip to the code behind view, and to get to that you can go to your Solution Explorer, you can twirl open your form, and then you'll see a class file located below. You can just double click on that and that will launch you into the file. So inside this file we have our basic form class, and then I've created a method called calculateInterest. So let me go back real quick and explain the way this app is designed to work. It models similarly to what is in Chapter 3, but it's not verbatim, so I wanted to have a little bit of difference just to really kind of show you a similar scenario, different context. So what will happen is we want to be able to put in an amount, put in an interest rate, hit the go button, and have the computer spit out to us the total amount of interest to be calculated based on that amount. So this method, calculateInterest, is designed to do that. So this method has basic elements. It has a return type, a method name. Anything inside of these parentheses are considered parameters. Each parameter has its own return or data type and variable name or parameter name. So you have a decimal amount, decimal interest rate, and then a boolean of return interest only. The body of a method inside the curly brackets is the code that actually gets executed when another piece of code calls this method. So what happens here is that the interest calculated is returned, and then depending on if this boolean is true or false determines whether it takes the calculated interest amount and adds it to the amount, or it simply just returns the interest owed on the amount based on the interest rate. Now, some of the things that are kind of unique to C# is that you actually can have optional parameters, and an optional parameter looks like this. It's data type, variable name or parameter name, and then there's a default value assigned to that parameter. So in this case, false automatically sets the return interest only parameter to false unless you explicitly in your call to calculate interest make this false. So what I'm going to do here is I'm going to go ahead and I'm going to double click on my go button, and that's going to generate my event handler. And then I'm going to take txt, actually let me make some quick adjustments here. We'll make this txt amount, and this will be txt rate. So we'll do txt amount.text, and this will be a decimal. And just to distinguish, I'm going to use a shorter variable name, so we'll say AMT, decimal interest rate, or IR, and then we will do decimal.tryparse, or string, and then AMT. We'll copy this line again, and txt rate text IR. So this reflects our amount. This is our interest rate. And then we will attempt to parse text values. I'm going to wrap this inside of an if statement and say if they both parse successfully, do the next step. So the next and final step will be to actually calculate the rate and put it inside of the label. So we'll have lblvalue.text equal calculate interest, pass in AMT, the interest rate, and we have, again, this is an optional parameter of return interest only, and I'm going to want it to return interest only, so I'm going to set it to true. And then what this is going to return to us is a decimal, so I'm going to call toString, and that'll take that decimal that's returned and convert it to a string and put it inside the text box. So if we start our program up, we get our little box. We can say $100 and 10% interest. Oh, our label's above there, and it actually returned our value. Got some labels misnamed, which isn't a big deal. Can take care of that pretty quickly. So this label is actually called label 1. So we will call it LBL interest calc. And I accidentally created this form load, so I'm going to go ahead and delete that out. So we'll do a start. And I actually did this intentionally to show you this error. It's going to tell me that there were some build errors, and I'm going to go ahead and say, would I like to continue with the last successful build? No. It's going to bring up my error list and tell me that CP week 3.form1 does not contain a definition for form load and no extension method exists. I'm going to double click on this line, and it's going to take me to that point in the code where I'm getting the error. Now, form load is the name of the method that I deleted. What you're looking at here is the event handler wire up, and I'll talk more about this in just a few minutes. But basically what this is saying is that there is a load event that happens, and we are adding an event handler to the load event, and that event handler is going to call form1 underscore load, our method. And the reason we're getting this error is that that method no longer exists, therefore this statement is incomplete. So I'm going to go ahead and just delete this line, save, and then we should be able to recompile. Now you may be wondering, where does this live in the grand scheme of our project? It's actually inside of the form1.designer.cs. If you remember from week 1, this is where all of that code is auto-generated by Visual Studio from using the designer. So it creates our labels and controls and initializes them and sets our initial values from our properties dialog. So we'll hit start again. Everything will come up. Say the amount is 100, the interest rate is 10%. Hit go, and $10 is the interest we owe. Now we can do a few other things with our methods. One thing that is nice is, so we have this return interest only, and I'm actually going to change this and make this true by default, and then we can drop this parameter. But what I'm also going to do is I'm going to modify this parameter. I'm going to put the keyword ref in front of it. Now what ref does is it says that this value, amount, should be passed by reference. Now if you have ever used C++ or C programming, you'll be familiar with this concept of passing things by reference or by pointer. The basic idea is that instead of passing a value, passing the number that's inside of the variable amount into the function, creating a copy of it, we're actually passing the memory address where amount lives, so that when the value of the amount variable is actually updated, potentially inside of the function, that amount, or rather that value, actually gets written back to the same memory address as the variable that was used in the call. So what that does for us is that it gives us this ability to move values in and out of methods, similar to the out keyword, allowing us to pass values or get values out of a method as a parameter. So to demonstrate that, I'm going to go ahead and make this a ref, and then what we're going to assume now is we're always going to return amount times interest. I'm going to move that to the bottom. And I'm going to say if we're not returning interest only, then we want to take the amount, set it equal to the amount plus the amount of interest. So we're basically going to update the amount value with the newly calculated amount, but we're going to return the interest part as the return type. So when we run our method now, we have to add ref in front to comply with the method signature, and the amount variable will actually be updated. So I'm going to use the message box show, and I'm going to say new amount AMT toString. So if we run it again, 100, say the interest rate is 10%, and hit go, and it'll say that the new amount is 100. Close this, and then I'm going to add this return interest only, and I'm going to set that to false. So if we recompile again, 100, 10%, hit go, we'll now see that the new amount is 110. We'll also notice that the interest owed is actually $11, not 10, and that's because of the order of execution. To make that correction, we'll actually need to do this. We're going to say that create a decimal of interest amount and set that equal here, and then instead of doing the calculation twice, we'll just say interest amount, and we'll return interest amount. So this will calculate interest amount, check if return interest only, return interest amount. F5, 100, 10, there's 110, and there's 10. Great. So those are the basic ideas. Additionally, we could have a data or a parameter here that is out decimal new amount. So then what would be expected in our signature is that we would actually declare out new amount, or new val, let's say, and then we would have to create a decimal called new val and not set it to anything, and then it gets set when this method is called. So that's another approach to passing additional values in and out of methods without just using the return type. So you see that often with the try parse methods, but there are other approaches as well. Okay, so that is the coding methods. It's very similar to what you've probably seen in Java in the past. It's nothing unusual or out of the ordinary. It's just a slightly different approach to doing the same thing, and then there's some of those additional enhancements to the C# language that help make unusual things where you have parameters that may be optional, not required, making them easier to utilize. One other piece I did want to just mention is that if you have a lot of optional parameters, it gets a little weird trying to deal with optional parameters maybe in the middle of a method signature and so forth. So you can actually call out which parameters are which. So for example, if we wanted to pass in the interest rate first, we could say interest rate colon, and then we could say amount colon, and we can say ref AMT comma return interest only colon. So the part to the left of the colon is the actual parameter name. The part to the right of the colon is the value that's being passed in as that parameter. So that gives you a greater level of flexibility when you have a lot of optional parameters, or you, for whatever reason, maybe it makes more sense to pass them in a particular order, in terms of how you're dealing with the application. So whatever your reasoning is, that ability is there within the language as well. It doesn't change execution, it doesn't do anything like that, it's just there for aesthetics and coding. So the last thing that I want to cover real quick is events, and I want to cover them in a little bit more detail. So when we have a form, we set up an event or an event handler traditionally by just clicking on a control, double clicking that control, and then we get either the default event, or you can click on a control, go to your properties dialog box, identify the control that the event that you're wanting to handle, double clicking that event, and then it will generate an event handler for you, a method. Now these methods are actually wired up in a very unique way, and they're unique in that the methods always have to comply with a specific type of signature. So you have three basic components to an event. You have the event, which you can almost think of like a variable. Then you have the event handler, which provides the signature definition for the method that is handling the event. And then you have the handler itself, which is the method. Your event handlers are called I should say that they're a specialized type of delegate. And what a delegate is it's a class or object or variable that holds reference to a method. So just the same way you can declare a decimal and store a number inside of it, you can create a delegate variable and you can store a reference to a method, and then you can call that delegate just as you would that method. So let's kind of look at some concrete examples to really get our heads wrapped around all of this. So form load. I brought back form load again. I'm actually going to jump into the designer this time, and I'm going to scroll down into the generated code and look at the form load. So you have three basic pieces. You have the event load. And if we mouse over it, you'll see that when it was defined using the event handler data type or delegate type, and that basically is the signature that's expected when you're wiring up a method to handle the load event. The plus equals is unique only to events, and it allows you to connect multiple event handlers to an event. And then we're creating a new instance of the system.event handler. We click that and do an F1 here and pull up the MSDN information on this, you'll see that this event handler, when it was declared, is public delegate. The return type is void. That's the name of the event handler. And then it takes an object as a sender and event args e, and that'll come into importance in just a moment. So we then have new system.event handler, and we pass in a method form1_load. This form1_load is this method, and you'll notice that the method signature is return type void. Then the two parameters are object sender event args e, void object sender event args e. This method signature must match this delegate event handler signature. If they don't match, it won't compile, and that is basically the contract between the event and the event handler. So when the form load event happens, the code that fires off the load event knows that any delegate method event handler that is executed is going to expect these two parameters, an object of sender and an event args e. Now, whether you choose to use these arguments is completely up to your discretion. Sometimes they have value, sometimes they're just there out of compliance to, provide consistency. So, in our button click, we don't use the sender, we don't use event args. Event args by itself is actually a very simplistic class. It's a base class that more specialized event arg types kind of override or come out of. If it's just the basic event args, they're generally useless. There's no real value to them, but there are specialized event arg types that are of value. For example, if I'm clicking on the form, going to my events, and I'm going to wire up the key down event. You'll notice here it has a very similar signature, void, object sender, and then it has key event args. So looking at event args e in the form load, it just has equals get hash code get type to string, nothing fancy. If you look at key event args inside of the form 1 key down, you have a boolean of was the alt key pressed, was the control key pressed, was the key press event handled, so you can actually block the traditional response to that key press. If you set this to true, then if you're in a text box, for example, that key, that value, will not actually get injected into the text box. If you leave it at false, which is the default, then the key, the character, will actually get input into the text box if that were the case. You have key code, which is an enum, key data, which again is an enum, the key value, which will give you the character value of that key that was pressed, if it exists. Any modifiers, maybe that Control, Alt, and Shift were held down at the same time. A boolean if Shift was pressed, and then you can also tell it whether you want to suppress the key press event. So you have a lot more control, and some of these actually send information back to the control depending on how you handle these key event args. So there's definitely value there, and you want to make sure that you pay attention to what's going on with these particular event args, because you might be able to control certain elements of your program's execution, or you might gain insight into what happened when this event occurred. So those event args are very important, but the thing I really want you to kind of take away from this is that these events are really no more than a specialized type of property or variable. They are events, and then you're basically pointing a method to that event and saying, this method complies with the contract for this event handler, and when this event occurs, call this method, and then this method will do some action and then continue on execution. So that's the basic mechanics of how events work. There really isn't that much detail to them. We'll talk in later chapters about how you can create your own events and attach them to your classes, and what value that really brings to your programming, so that you're able to do more sophisticated things and being able to communicate information back and forth across classes, and classes that maybe have dependencies on one another. So for this week, this is a pretty simplistic lesson. It's not anything very complex, but it's still a fair bit of review. But I wanted you to at least be aware of it and be cognizant to any sort of syntactical changes that have happened between what you've seen in Java in the past and what you see in C#. Have a good week. I'll see you next week.